All right, come back. All right, so let's dive into this picture. First of all, let's talk about this picture. We know nothing about this picture until we start reading these sentences. When we look at this picture, we know nothing. We don't know what's congruent. We don't know what's parallel. We don't know what's perpendicular. We have 4 lines that are intersecting at different places. L and M never intersect on our picture, and P and N never intersect on our picture, but who knows what happens off of the picture. So all we're looking at is 6 different angles created by 4 different lines. Everybody okay with that? All right, once I get down to here and I see that I'm given that angles 2 and angles 5 are congruent, what I want you to get in the habit of doing, and would you please join me here, is get your pencil and lay your pencil on the line that 2 and 5 share. So if you look at that line there, 2 and 5, you can see 2 and 5 are first of all on alternating sides of that line, that transversal, and they're both tucked inside of lines L and M. So we can define 2 and 5 as alternating interior angles. Now what Euclid gave us, where he said if your alternate interior angles are congruent, then your lines are parallel. And that converse of that theorem helps us understand that. So we need to take a little side trip and go back and talk about what it is that we knew before we walked into this unit. If I had 2 lines that intersected, we knew that I had vertical angles. I knew that lines 1 and 2 were vertical and angles 3 and 4 were vertical. I knew that angles 1 and 3 were supplementary, 2 and 3 were supplementary, 2 and 4 were supplementary, 4 and 1 were supplementary. That's what I knew before I walked into this unit. This unit introduces a second line that's intersecting this transversal and introducing a set of new angles. And we talked about how they were like different angle families. And that transversal links those 2 angle families. So I have also vertical angles, 5 and 7, 6 and 8. I have also linear pairs, 5 and 6, 6 and 7, 7, 8, 8 and 5. But it's the story between these 2 angle families that is what Unit 3 is all about. And knowing that story can tell us whether or not the lines are parallel. If we're given the lines are parallel, then we can start talking about all kinds of cool relationships. Corresponding angles, congruent. Alternate interior and exterior angles, congruent. Same side interior angles, supplementary. But that's only true if the lines are parallel. When we take it one step further, we're introduced to this idea of the converse. And what the converse says is if you're given those fun relationships, then you can go ahead and prove that the lines are parallel. Every single time that you are proving parallel lines, that's when you need the converse. If you're not given them and you're proving them, it's the converse you need. All right, so let's talk about the next set. I've got angle 2 and I've got angle 4. If you take your pencil and do what we tried to do before by coming up with the transversal that angle 2 and angle 4 share, you can't. There's no line that angle 2 and angle 4 share. 4 is made up of M and P. 2 is made up of N and L. And as much as you want to think all the lines are parallel, or the other reasons with the other angles might prove that they're parallel, in this isolated scenario, just having angles 2 and angle 4 there is no relationship. And the reason why there's no relationship is there's no shared transversals. So because I have no shared transversals, I can't say anything about angles 2 and 4 without some more information. All right, let's talk about angles 1 and 3. If I have angles, and we'll come down here, if I have angle 1 and angle 3, if I go to put my pencil, I can see they both share line L. And they're in corresponding positions or matching positions with their lines. They're both sitting on top of their lines, and they're both on the same side of the transversal. So that means that angles 1 and 3 are what we call corresponding angles. And given angles 1 and 3 are congruent, I know that line N is parallel to line P. All right, let's check out angles 1 and 5. So if I come over here, I've got 1 and I've got 5. They're sharing transversal N, and they're in the same position on L and M. If you're not laying your pencil down on the picture, you're not taking the opportunity to see every single possibility of what is out there for you. Same side of the transversal, nested into the same place, so that I know then L is parallel to M because they are corresponding angles. And it's the converse that makes them parallel. Same as up here, it's the converse that makes the two lines parallel. All right, let's check out 3 and 6. When I'm looking at angles 3 and 6, I have angle 3 here, angle 6 here. Take your pencil and lay it down. They are on alternating sides of the transversal, and they are outside of these two lines, L and M. So 3 and 6 are going to be alternating exterior angles. 3 and 6 are going to prove that L and M are parallel by the converse. Now, if you're passively sitting there and not doing, I'm going to ask you to do this one. Pick up your pencil and try to find a transversal that 2 and 6 share. I'm putting my pencil on all of the lines, and nothing contains both 2 and 6. 6 is made up of P and M. 2 is made up of N and L. So angle 2 and angle 6 have no relationship because they have no shared transversals. All right, with your partners, please, as a table group, talk to each other and say, which one of these do you find to be the stickiest? Which one do you think is the hardest? Go. All right, come back. All right, flip the paper over. Let's take a look at these proofs. I love this first proof because it's so simple in its application. It's so simple. There's only 5 lines to it, and 2 of which are the given. So if you're curious what I mean by that, look, given L and M are parallel. All right, I'm going to draw my little triangles. Angle 1 and angle 2 are congruent. I don't see that there. I'm curious. Look at this. They held on to it until they needed it. So if there's something in your given that you don't see initially, search down. Maybe they added it later when they needed it. They needed it in a couple lines, not quite yet. It's your choice whether you're going to list it all at the same time or list it when you need it. They're both good. They're both going to get you the right answer. You're fine. All right. Because L and M are parallel, I can say that 1 and 3 are congruent because they are corresponding angles. We're not going to get tangled up in whether it's a postulate or a theorem. To be honest with you, I don't care. If you want to be specific, it's a postulate. It's the one that Euclid gave us. It's the one freebie Euclid gave us. We don't need to put the word converse on that because I'm given the lines are parallel, so that's the cool relationship. So check out my chart over here. If the lines are parallel, then I've got different kinds of supplementary and congruent relationships. Here's my congruent ones. Here's my supplementary ones. This is my initial relationship that Euclid gave us. If the lines are parallel, then. All right. So now that I have the 2 lines, I have these 2 lines parallel, and I have 1 and 3 congruent. Now I go back because now I care about 1 and 2 being congruent. 1 and 2 are congruent, and that's given. Now I can say angle 2 and angle 3 are congruent because, do you see this link between angles 1 and 3? 1 is congruent to 2, 2 is congruent to 3, and I have 1 is congruent to 3. 1 is congruent to 3, 1 is congruent to 2, 2 is congruent to 3. That's my transitive property of congruence. It can't be substitution because I don't have any numerical values. Make sure you see that link between 1 is congruent to 3, 1 is congruent to 2, therefore 2 is congruent to 3. Now that I have angles 2 and 3 congruent, I want you to pay attention to what that means for lines A and B. And this is where my converse comes into play. Because angles 2 and 3 are congruent, and because angles 2 and 3 are alternate exterior angles, I know that A is parallel to B. The reason why this proof is so beautiful is because it uses both the given theorems and their converses at the same time. I'm given these lines are parallel, so these are the cool relationships I have. Now I use my transitive property to get a new set of relationships, and now I can prove those lines are parallel. The converse is what you use to prove the lines are parallel. What do I see? What do I know? What do I need? I see a line system. I know these 2 lines are parallel, which means these 2 angles are congruent. I'm given these 2 angles are congruent, so my transitive property gets me what I need to prove these 2 lines are parallel. All right, let's look at the second proof. I'm given M and L are parallel. I'm given 1 and 2 are supplementary. Now here's the deal. Once you know that they're supplementary, you know that their measures add to 180 degrees. I'm not going to deal with that. If I start talking about angle measures, I got to use the definition of congruence. I have to add, subtract, multiply, and divide things. And we know of a shorter way to have to deal with that. First of all, M and L are given to us. Here's this second part. Notice it doesn't come down until, again, the end. Whether I list it all at one time or separately, it doesn't matter. I know that 1 and 3 are congruent because these lines are parallel and 1 and 3 are alternate interior angles. If the lines are parallel, those core relationships exist. Now I have 1 congruent to 3, 1 is supplementary to 2, which means that angle 3 and angle 2 have to also be supplementary. That was that theorem called congruent supplements. And here's how that one goes. If I have two angles that are supplementary, I have angle 1 and angle 2 supplementary. If I have another angle over here named angle 3, and he happens to be the same measure of angle 1, if these two are equal and these two are supplementary, that means that these two are going to be supplementary also by the congruent supplements. Now we proved the congruent supplements by using the definition of congruence to change everything to angle measures, by adding them up to 180. Nora, put it away. Off and away. So the congruent supplements saves me all that time from converting things to angle measures, adding them to 180, setting them to equal to each other, subtracting 180, and proving that they are the same measure and therefore congruent. That congruent supplements theorem saves me that time. All right, what's the so what, now what? Now that I have 3 and 2 supplementary, that gives me what I need to get A and B parallel to each other. A is parallel to B because I have consecutive interior angles. Converse tells me if they're supplementary, then those angles are going to be congruent. What questions do you have? All right, take out please your review packets. All right. So I'll ask for your attention back again, and it goes like this. When I ask you what questions do you have, and you say none by a deafening silence, and then I ask you to get a piece of paper out, and you're all talking about questions that you had, how's that benefit the group? Because here's what it does. You delay what we're talking about. You're asking your group mates who are now not listening to me, and there's a chance that everybody else could benefit from your question. So if there's a question that you have about either of these, speak up. Talk to me. All right. So I'm trusting you watched the video to check your work with mine. So all of these relationships And then once I find out that the lines are parallel, I can say whether or not they're supplementary, congruent, and the reasons for why they are. These two angle systems were the ones that were on versions A and B of the quizzes. Hey Cole, can you put your head up? Thanks. Any questions on any of these? Ones you want clarification? How'd you get that answer? Tell me more about. I'll be glad to walk you through the daisy chain of solving for any of these angle measures at the bottom. Go ahead.
For the second one, for 3 and 10, wouldn't they be supplementary? So when like 10 be 53?
So there's no reason for me why 3 and 10 would be supplementary. So 3 fits into this angle system. Once I know this is 53, I know 2 is 53, 1 and 3 are supplementary to 2, and 53, that makes them 127. Because these two lines are parallel, I can get from 5 and 2 are alternating interior angles. 5 and 4 are complementary because they're supplementary to a 90-degree angle. Again, because of these two lines being parallel, I get 5 from 2, I get 4 from 5, and 4 then gives me 7. Once I have 7, I have 8 and 9 and 10. So 10 and 3 don't have any relationship because they share this line, but they don't have that second line that helps them out. So this is the angle that sets up 3. This is the angle that sets up 10. So 10 and 3 don't have any story. Go ahead.
The question, this is 1 and 11 are joined, but there's no 1 and 11, right?
Sure, it's right there.
Oh, in front of
In the diagram above. Go ahead.
On the first question, between A and B, how many distance?
A and B here.
Yes.
So 2 and 4 share this transversal. And then the same position of N and M. So those are corresponding angles. And then 6 and 5 share this transversal. But see how 6 is underneath my line and 5 is above? They're same side interior angles because they're both inside of these angles. Does that help?
Yes.
Okay. Anything else on page 1? Page 2. Each of these we were given parallel lines. So we set up the relationships, whether they are equal, whether they're supplementary. Any questions on these 3 through 8? In the next section, 9, 10, 11, if you are given the slope, parallel slopes are the same, perpendicular slopes are opposite reciprocals. If the parallel line is positive, the perpendicular line will be negative. If the parallel line is negative, the perpendicular line will be positive. And then it's the reciprocal. If it's steep, the other one will be flat. This section I loved because it was like a real quick justification practice. If you're given these two, what are your conclusion? Definition congruent says that they are congruent. If you're given 3 and 4 or a linear pair, the conclusion is that they're supplementary by the linear pair postulate. This is my symmetric property of congruence. I'm just flipping the order. If I'm given x as the midpoint, then I know that these are two congruent segments. If I'm given that AD is the bisector, then I know that those two angles are going to be congruent. All right, tell whether the lines are perpendicular, parallel, or neither. Neither because they're not opposites. Perpendicular, parallel. So lots of kids asking questions about this justification here. If the proof or if the theorem doesn't have a specific name, just describe it. If two lines are parallel to the same line, then they're parallel to each other. It doesn't have a name, but I can just describe it.
Can you go back up to number 12? How is that neither? Because when 2 over 1, we have to 1 part.
They're reciprocals, but they're not opposites.
Yeah, okay, you're
Yeah.
right,
Okay. Down here, I love paragraph proofs because to me they're just more natural. Since A and B are parallel, I know that 1 and 4 are congruent because they're alternate interior angles. Since C is parallel to D, I know 3 and 4 are congruent because they're corresponding angles. Using the transitive property congruence, since 1 and 4 are congruent, 4 and 3 are congruent, I know 1 and 3 are congruent. That's kind of easy to follow. On the back, again with just, we've seen this diagram so many different times. Given these two lines are parallel, I can come up with some cool relationships. Once I get those cool relationships, I can use them to prove the other lines are parallel. I'm assuming you guys looked at these on the video. L and N are parallel. 6 and 12. Parallel. So I work my way back through what I need to get J and K parallel. All right, the last part, ECART practice questions.
It's 6 and 12. It's 6 and 3.
Isn't that 12? But I used angle 2. I used angle 2. 1 is D, 2 is G, 3 is G, 4 is J, 5 is A, 6 H, 7 A, 8 G, 9 C, 10 F. Any questions? Anything I can help you out with?